What's happening, hardscapers? This is episode 52 of the How to Hardscape podcast, where we talked with you about how you can start and grow your hardscaping business. And today we're joined by Tyler Matys, president of Risi Stone and Ray Rodenburgh of Unilock. We take this episode to discuss retaining walls and a lot of information in regards to constructing one, what needs to be considered, and a lot of valuable resources available to you from Risi Stone and Unilock. So you'll want to tune into this episode all the way to the end. And without further ado, here's our interview with Tyler and Ray. Today, we're joined by Tyler Matys of Risi Stone and Ray Rodenburgh of Unilock. They're both here to talk with us about an important subject, that of retaining walls. Tyler and Ray, thank you so much for joining me here.
Thanks for having me.
Hey, it's good to be here.
It's great to have you both here. Ray is a veteran guest on the show with his third appearance here. So our audience knows a lot about Ray, but Tyler, let's get started to learn a little bit more about yourself. Can you give our audience a little bit of a background about yourself in the industry?
Yeah, sure. I'm Tyler Matys. I'm the president of Risi Stone Retaining Wall Systems. I can't believe it, but I'm a 25-year veteran of the industry, which blows my mind. But I've been doing this for quite a while. And Risi Stone, if you're not familiar with the company, we're basically the inventor and the pioneer of the segmental retaining wall. It started out in the early, 1970s when the founders, Angelo and Tony, purchased their uncle's block plant in Gormley, Ontario. And they started manufacturing retaining wall products at that time. And then I think in the early 90s, they sold their manufacturing to Unilock and became just a retaining wall licensor. And about the mid 90s is when they hired me straight out of school, and the rest, I guess, as you can say, is history.
Absolutely. So obviously there's quite a history there with Risi Stone. Can we talk a little bit more about that and say their introduction into the industry? What did that look like? What was that first product that was offered? Can you give us a little bit more of a background on that?
Yeah. So the plant, the original plant made building blocks like cinder blocks and patio slabs and that sort of thing. And Angelo Risi was actually a civil engineer. And his brother Tony kind of handled more of the construction end of things. And they started out by taking basically what's a patio slab and putting a integral tongue and groove into it and stacking it up instead of laying it flat. And that was kind of the first product. It's called Risi Stone, which is kind of like an iconic product in the industry. It's about 3 inches thick, about 2 feet long, and about a foot deep. And that was their first patented product. But it was mainly used to build like smaller landscape walls, planters, that kind of thing, maybe up to about 3 or 4 feet in height. It wasn't really until I think the early mid 80s that geogrid reinforcement started being used, and they could build the walls a little bit higher. But that's kind of how they got their humble start, and it took off like crazy. I think I look back at some of the old articles that were written about the Risi Stone system as being sort of this revolution. At that time, people were just either dry stacking natural stone or using reinforced concrete walls for retaining walls. So it was really a different way of looking at things. And I think the Risi brothers were credited for sort of starting the SRW industry.
So since that first Pisa wall, how have you seen this industry change, say, looking back at that point or from the point to which you entered Risi Stone? How have you seen this industry change over this time period?
Yeah, so it's definitely undergone like dramatic changes over the last 2 or 3 decades. And I think the main thing is it's just become a lot more sophisticated. Like I know from an engineering point of view, I think when I first started, there was some pretty basic design methodologies and so on. Even I think a lot of contractors were kind of using general rules of thumb for how high they could go and so on. And that didn't always work out. But now, over the last 20 years or so, we've got proven, vetted design methodologies and construction best practices and so on. We've sort of taken what people considered to be a landscape wall, and without really much regulation, and kind of brought it into the stature where it should be, where it's a designated structure according to the building code, like any other structure, and it's taken kind of seriously that way. Risi Stone and Unilock together, we spent a lot of time working with government bodies and industry associations and so on, so that retaining walls were treated with the same kind of level of respect, I guess, as other structures. So, requiring proper engineered design, on-site inspection, and then obviously from the material side, stringent quality controls on the actual product themselves. We've also kind of developed some pretty sophisticated design programs and tools to analyze the walls, so that we're making sure people have safe solutions out there.
Yeah, this education is so important, and we're gonna come back to this. But I noticed you mentioned Unilock a couple times in there. So Ray, what is Unilock's relationship or partnership with Risi Stone in terms of everything that in terms of retaining wall products?
Our history, and actually my personal history, goes back before Unilock. Actually, I've been at Unilock for 31 years, as you know, but prior to that, when I was a contractor, I, like a lot of contractors back in the day, we graduated from railway ties to beautiful 6x6 pressure treated timbers. And I remember coming through a subdivision where I saw this Pisa 2 wall. I didn't know what it was, but it was a brown Pisa 2, kind of a circular planter that was jutted out of an embankment in the subdivision there. And I was so impressed. I thought, okay, I got to get that. And I never looked back. Actually, that became my my go-to wall. I think I used more brown Pisa 2 than anything else. I did a little bit of Pisa Stone, but mostly it was Pisa 2. Yeah, and then moving on, when I started at Unilock, we really didn't have a retaining wall. We had another product called Slope Block, and it had a couple of iterations, and we did well with that product, but it didn't have a lot of the features that a lot of the Risi products had. And when Risi Stone decided to go into just like licensing the product to manufacturers around the world, we were approached to buy their manufacturing facility in Gormley, and then from there it took off and grew, and it was a really good accompaniment to our other paving stone products. It was just a natural fit, and it's been a good relationship. And as the industry progressed, as just like Tyler was saying, the engineering, now we've gone to a level of sophistication with it. There was a day where a guy would say, "Oh, how high can you go with Pisa 2?" And we would just say 4 feet. But that was
a
you remember those days. Those were the scary days, And then he would build a 4 foot high retaining wall, and then park a Hummer right next to the edge at the top of it. So I think there's been certainly some industry growing pains that way. But what impresses us the most is that Stone has taken the high road, if you will, on the engineering, and has really led the industry in a lot of ways with retaining wall engineering, and so it's been a really good partnership.
Absolutely. And you mentioned an interesting thing there, which is a great segue to my next question. In terms of engineering, Tyler, why is retaining wall engineering so important?
Well, I think retaining walls, by their very nature, they're holding back thousands of pounds of pressure, and we have to do it safely. So a failure in one of these types of walls could be disastrous. That's why we take it so seriously. Like, we have walls holding up highways and high walls 20 feet high, next to schools and that sort of thing. So we really do make every effort to ensure all the elements have been designed properly, with a lot more strength than what's absolutely necessary, so that we don't have any issues. And it's not just the design. We've been really big advocates for getting proper inspection on the site. So, you've got really three aspects to this thing. The design itself has to be done really well. There's got to be really good inspection, and then there's got to be great construction practice. So the three of those things have to come together, and we've worked pretty hard to try to, obviously work on the design, but then the other side of things, I think, is the education component for even for the geotechnical engineers out there that are doing this inspection. We really try to make their job easier by giving them simple checklists and that sort of thing, so that things are done right. We've been very lucky in Ontario. We've never really had any major issues, and I think a big testament to that is the fact that we have a lot of different people working together to make sure these walls are designed and built properly.
And Tyler, I also think that what is unique about Risi Stone is the variety of products that you have. That you can adapt to different situations and help you engineer them efficiently.
Yeah, that's a great point. I think it's also like a testament to Unilock's commitment to providing their customers. People don't necessarily realize it. To have just one wall system is a huge expense. It costs a lot of money in molds and all that sort of thing. But Unilock, we've developed them, but Unilock has gone ahead and manufactures a very wide range of products, which makes our job easier as engineers, because we can look at a site and say, okay, we have a whole toolbox full of options here of what would best suit a particular condition and so on. So we've got products like DuraHold, for example, that's about 1,700 pounds a unit, and we've done some pretty amazing heavy duty engineering projects with that, right down to something like a Rivercrest product, which is a natural kind of flagstone looking wall for smaller walls and so on. So and everything in between. So it's been a great relationship that way too.
Yeah, and speaking of which, with engineering, my introduction into this industry was from the supplier end, and just explaining to not only retail customers, but some people starting out in the contracting world, what goes into building a retaining wall is more than just the wall itself. There's so much engineering involved, and explaining to them, like showing them that the cost of materials are just going to skyrocket. Besides the retaining wall, because of that engineering, to make sure that that's going to stay in place. A lot of people don't understand this, who are maybe not in the industry, which becomes more apparent as I became a contractor and explaining to customers then that, making sure that retaining wall is constructed properly is so important. So Tyler, what are the main factors that affect engineering in a retaining wall? What should we be looking for to decide what goes into building that retaining wall?
Right. So the main things that we look at right off the bat are obviously the wall height. The higher the wall is, the more critical it is. The larger the wall has to be, just based on the simple fact that earth pressure increases with depth. So the height of the wall is the main one. We look at loading behind the wall. For example, if there's very steep slopes, that increases the pressure behind the wall, or if there's a presence of water either in front or behind the wall, or other structures nearby, such as a building footing or something like that, or even traffic loading. So for example, if you're trying to hold up a roadway or a highway, that's going to exert more pressure on the wall. So all of these factors kind of come into play when we're doing the engineering, and they'll have a big impact on what the final design looks like. Even things like soil conditions, holding up a really high quality gravel material is going to be easier than holding up, say, a native clay. So that would affect the size of the wall we need and that sort of thing. So those factors all come into play. And then I guess from the design end of things, once we figure out what the loading is and the height of the wall and so on, we look at how much room we have to build the wall. That's usually a critical factor. Everyone wants to push their walls out right to the property line, which can sometimes be a bit of an issue. So a very high wall close to a property line, we might be looking at something more of like a gravity wall rather than a geogrid reinforced wall, because it takes up a little less space. But either way, in our office, we've got 4 full-time professional engineers with about think about 75 years of combined experience. So there's not much we haven't seen. And although most projects provide some kind of challenge, we can usually provide a solution for just about anything.
And can you explain a little bit about the different elements of a retaining wall? I know it's a very broad question and it's very site specific, but for a general retaining wall that you might see, what are we looking at in terms of installation and the different materials that would be used with that retaining wall, in behind that retaining wall,
right,
and so on?
Yeah, so there's different types of structure types that you can build. The first is like a gravity wall. A gravity wall just uses the self weight of the SRW units themselves to resist the soil pressure. So a gravity wall is the simplest type of SRW. You know, you're kind of limited to how high you can go with that type of wall unless you start getting into bigger versions of it. Like we have a Sandstone 925 wall, which has a 3 foot thick or 3 foot deep base unit, and we can go fairly high with that. 8 or 9 feet. In some situations. So that's a very simple type of wall. We're basically just using the weight of the mass of those units, and then we have a drainage layer behind it, and that's pretty much the wall. Underneath it, you have a basic leveling pad, which is a compacted gravel leveling pad. Then as you start getting higher, you can use something called the geogrid reinforcement to start constructing the wall even higher. And with this, geogrid is like best way to describe it is like a high strength mesh, and it's usually made out of polyester and coated in like a polyethylene, and it's used as a tieback in the soil to kind of reinforce the soil. And we've constructed walls 30, 35, 40 feet high with the geogrid reinforcement kind of doing most of the work. I think the best way describe it kind of in lay terms, the geogrid works kind of like reinforcing steel and concrete. It provides like that tensile element. Compacted gravels and so on are very strong in compression, like pressing down on them, but they have no strength when you're trying to pull them apart. Just like concrete has a lot less strength in tension. So these elements added in layers add that tensile capacity, and we end up creating this what's called a composite mass. So it works very well, and we've been able to construct some pretty impressive projects using both of these methods, the gravity walls as well as the geogrid reinforced walls.
So sticking on this topic of installation a little bit more, and Ray, I'm sure you have a lot of knowledge in this this category as well. A lot of guys, have used A gravel, granular A for their bases in the past, and we're seeing a shift towards using 3/4 clear. In terms of, say, an installation of the extending past the wall as well as extending in front of the wall for the base, and the placement of a drainage tube in behind the wall. Can either of you two speak a little bit about that?
I think that's I think Tyler realm there in terms of what's required in an anchored wall. I can certainly tell you what I see in the field, but some of it may not conform to what is the absolute best practice. And actually, Tyler might even agree that there might be, several different ways to approach, the installation.
Yeah, the base is obviously a very, very important part of the installation, because that first course that goes down on top of it, depending on how well that goes in, everything else is going to be affected by it. So contractors usually spend quite a bit of time with the base in the first course, so it is a pretty important element. As far as the material goes, we usually spec a granular A as our base, which is like a well-graded gravel. We like that. It compacts very well. You can use a more of a gap-graded material like a 3/4 clear. The issues you get into a little bit more there is it's a little bit more difficult to level just because of the size of the aggregates. That's the first thing. And then because you've got big open voids in that aggregate, there could be a tendency of, when you're compacting them, driving them right into the subgrade, whereas you don't have that with a a granular A, which is a well-graded material. It has, it's very tight and compact and doesn't have as many voids, so you don't get material migrating into it. So we like the granular A as a base. Usually it's compacted to 98% standard Proctor density. So it makes a very solid leveling surface. The NCMA, which is the National Concrete Masonry Association, they're sort of the governing body on best practices and construction guidelines. They're recommending a minimum 6-inch thick base, where the base extends 6 inches in front and behind the block. Risi Stone has sort of always had a bit more of a rule of thumb where we say whatever the block thickness is, that's how thick the base should be, and that's how far it should extend in front and behind. So for example, our Pisa 2 block is at a 6-inch height. We specify 6 inches in front, behind, and deep or below. Sienna stone is 7 inches, just over 7 inches. So we up it a little bit to 7 inches in front, behind, and below. And then Durahold, which is 12 inches, we do the same thing. So we kind of have there's a minimum industry standard, and then we have a way that we know that sort of best practices worked for years for us, and that's kind of what we follow. You also mentioned the drain behind there. There's a couple different approaches. Typically, if there's a catch basin to connect into or some kind of a positive outlet, we like to see the drain at the very lowest point in the wall, which would be just behind the gravel base, sitting kind of just above the foundation soil. That's going to collect everything, but obviously you got to make sure that you've got somewhere to connect it to. It's got to be a positive outlet. If you don't have a catch basin nearby, the other option is to outlet the drain through the face of the wall, which is done quite a bit as well. The only thing you have to keep in mind there is if you're putting the collection drain basically above grade in front of the wall, you got to make sure that the material that's compacted underneath the drain is a lower permeability type of soil, so that water percolating down through the reinforced zone gets picked up by the drain and kind of stopped there, at least momentarily, so that it can get outlet through the face, as opposed to trickling down below the drain and just sitting at the base and having nowhere to go. Those are sort of the two main ways of looking at it.
Sort of in the non-engineered world, I know, because clear stone has taken such a hold in terms of the paving stone installation side of things, and guys have had really good luck with using the 3/4 clear with a small chip stone on top for leveling purpose. Mm-hmm. And we manufacture now a product. It's a base unit we just call it universal base unit, and leveling those in is ideal, especially on these small residential jobs, where if you can get all these base units in, then when it comes time to do the placement of the wall blocks, you have a nice surface to work on regardless of the weather. So, but again, you've got to make sure that first, what did you call it, Tyler? Toe in. That toe in is how deep is it typically for a 3-foot wall?
The embedment, or the amount actually buried, it's a minimum of 6 inches, or typically about 10% of the wall height. So a 3-foot wall, like Ray referred to, you want about 6 inches of the wall buried. So if you've got a 6-inch base and 6 inches buried, your trench would be about 12 inches deep from grade. But as you start going up higher, 10-foot wall, something like that, you start to go toward the 10%, which would be about a foot buried. And we can kind of follow those guidelines in general until it starts getting a little more complicated with steep slopes in front of the wall and so on, which require you to bury even more of it. But that's another hour session.
Yeah.
So continuing on here, in behind the wall, can you mentioned GeoGrid and what it is, and can you talk a little bit about how it's used in terms of behind the wall, what our drainage stone looks like, and as well as where does that GeoGrid I don't want to say typically because every wall is different, but typically go, and where does it extend to? Does it go ever past that drainage material in behind and into the native subsoil?
No, it's the reinforced zone is the zone behind the wall that's it's always excavated out completely and then backfilled. So typically a geogrid, the length of a geogrid is about 60% to 70% of the wall height. So 10-foot high wall, you'd have 6 or 7 foot length of geogrid, which includes the block facing as well. So you'd have to excavate back that full 6 or 7 feet to be able to construct the wall. So it's a completely kind of composite mass that you create. You never anchor it back into that soil. When you talk about a drainage layer, we're very fortunate in this market in Ontario to have a lot of high quality free draining gravels. So we actually construct our entire reinforced zone with something like a granular B or another type of well-graded free draining gravel. I know down in the US, a lot of locations, they don't have the availability of those materials. So as a result, they have a bit of a different method of construction where you create a 12-inch or 18-inch drainage stone layer right behind the block. And then that's followed by some type of engineered fill material, which is still what they consider granular material, but it can be have a higher fine content. So it might be something that's native to the site that's used there. So basically it boils down to if you have more than 8% fine material, fine content, which is like your clays and silts in it, you need to add those drainage layers behind the wall, behind the facing, maybe even behind the reinforced zone to catch any water coming in there. So that's kind of like the general construction of the wall. The geogrid is typically vertically spaced at about 18 to 24 inch centers until you start getting to very high walls, and then the geogrid starts to get very tight in terms of the spacing, 12 inches, that sort of thing. So that's the general arrangement of the backfill and the geogrid.
Perfect. And in terms of one final note on installation, as we build our wall up, how should our drainage layer in behind the wall be coming up with that wall? And should we be compacting it and so on? Can you speak a little bit about that?
Yeah, so right behind the wall, like I mentioned, if you're doing a drainage layer, the drainage layer basically comes up with the block. So you don't want to stack any more than about two blocks, 3 blocks at the most before you start backfilling with your drainage layer, or in the case of this market here, until you start backfilling with your pure gravel that's going to compose the entire reinforced zone. So that's how you kind of come up in terms of the construction of it. So you don't want to go much farther than that. Within about 3 feet or a meter behind the wall, the NCMA recommends you only use a walk behind hand operated compactor. This area here, you got to be a little bit careful. If you over compact, you can start pushing the blocks out during construction. So that's why they kind of recommend only the walk behind type of compaction equipment within 3 feet behind the wall. And then past that, you can go to the heavier stuff. But that sort of protects the wall as you're constructing it, protects the alignment of the wall as you're going up, and make sure that you don't over compact either your drainage layer or your reinforced material. Using
adhesive in your walls, would any of you be interested in talking about that?
Basically, adhesive. If you're building a smaller 2-sided seat wall or something like that, say with the Rivercrest product or something similar, because people are going to be interacting with that wall, sitting on it, and so on, it's probably not a bad idea to use an adhesive. But for typical structural wall applications, with geogrid reinforcement and so on, we do not require it, except maybe under the cap, the coping unit at the top. If it's a small hand placed system like Pisa 2, we'd say, glue the cap down, but something like Durahold or Sienna Stone, again, we don't require people to use an adhesive on that, but for the smaller, like I call them like backyard living walls and that kind of thing, then it's probably not a bad idea. I don't know. What's your thought on that, Ray?
Yeah, I totally agree with you there. You hit the nail on the head. Seat walls, grill islands and bars and pillars and things
Yeah.
like that, that maybe so to people sitting on them or leaning against them. It's a good practice to use some adhesive,
Yeah.
but they are called gravity walls for a reason. So for most applications, it's not required except for those backyards.
Awesome. So, with all of this said and all of this installation engineering, Tyler, what are some mistakes, and maybe you can speak on this too, Ray? What are some mistakes that you've seen contractors out there doing, or mistakes that when you look at a wall, you can say they didn't do this, they missed this? Can you talk a little bit about that?
I think since when I first started, way back when, the contractors have come a long way. And I think, to be honest with you, most of them nowadays are excellent. On occasion, I'll see the odd one. It's pretty rare, but I'll see the odd one taking GeoGrid and rolling it out along the length of the wall, as opposed to the way it should be done, which is cutting it to the specified lengths and running it perpendicular to the wall. So that's kind of one sort of rookie mistake that I've seen done before. But like I said, I think most contractors have come a long way. Back when I first started, like I said, there was guys sort of using rule of thumb and just stacking walls up without design or without drainage behind them, and those walls typically, had issues. But nowadays, I think most of them are pretty sophisticated. Unilock's done a lot of training. We've done a lot of training, and we create pretty extensive installation guides and so on. So most of the guys are up to speed, and luckily we don't see a lot of those issues anymore.
Yeah, I would agree. The only issue that I maybe see out field is when, and it's more just in landscape walls. Once you get into higher walls, the guys realize that they're on the hook for repairs, and they want to mitigate any liability. So they're all over the engineering, and we've people in our training sessions and we've kind of preached that story for quite a while. The residentially, though, you'll see projects that are, guys will think, oh, this wall's only 10 feet high or 3 feet high. I don't need an engineer, but not really paying attention to, some of the other loading conditions, drainage conditions, even global stability. I've seen like just 2.5 foot high walls built on an embankment, and that can be tricky too, because the embankment can slide. So it's usually some guys that get, they're the kind of the know-it-all guys that just sort of, I know what, this will work, this will be fine,
Yeah.
But I think sometimes we just have to take a little extra precaution. And as Tyler started out by saying, hey, this is a structural wall. This is a structure. Even if it is only 2 feet high, it's structural.
Yeah.
And so I think if people take anything away from this podcast, is that always think about the application and how it has to perform and what it has to do.
Yeah, and to add to that point, there's no reason not to get the Risi Stone and Unilock involved with the project. There's really no reason for it. We provide engineering design services here, and in terms of the cost, it's nominal. So there's really it's very cheap insurance to do it right, and believe me, it'll cost you a heck of a lot more to fix it.
Absolutely. And
yeah, oh boy.
In terms of that engineering, and we're based here in Ontario, so what is the say maximum height that you can go without engineering, and what is that threshold that then you need engineering?
The National Building Code requires an engineered seal design for walls 1 meter and over in height. There are some municipalities locally that actually require it for walls that are 0.6 meters over in height. So you kind of have to check with your local building department, but generally that's kind of where it sits. 0.6 to a meter in height.
So that's,
I think it's not
for
much
our
different
American
in the
friends,
US.
that's about 2 feet, right?
Right. Yeah. 2 to 3 feet. Yeah.
Gotcha. And once again, we hear Unilock coming up in conversation with Risi Stone. Ray, what are some of the products that we will see manufactured under license from Risi Stone?
Well, we've got quite a few. I'm not going to go into them because people can certainly go to our website, and 85 to 90% of the walls that we manufacture are all manufactured under license from Risi. But some of the famous ones, of course, are the Pisa and Pisa 2. We now have a Pisa Smooth up in Canada with a smooth face, as well as Sienna, which is a larger scale. Used to have a split face, and we also have a smooth face one now. Durahold has been sort of the industrial godfather of retaining walls. And then we have tumbled products such as Roman Pisa as well. And then we have an interesting product that is one that Tyler developed, and that is the River Crest. Tyler and his team, and in collaboration with some Unilock people, developed this fantastic. It's almost like drywall stacked flagstone look, but with a more engineered approach and also a rapid installation approach to that product. And certainly, if somebody hasn't tried it, and if you want that natural stone flagstone look, it's an excellent product.
Absolutely, and a lot of walls that are coming out onto the market that just look beautiful. And Tyler, and other than the appearance, how should a contractor be consulting with their homeowner or whatever it may be to choose a wall that's suited for their purpose? What should they be going through?
I think the best resource I think out of the gate is their Unilock territory manager, or they can give Risi Stone Systems a call. That's no problem. But really, what it comes down to is certain products lend themselves better to certain conditions or certain projects. So if you've got a relatively high wall, the contractor has to start asking themselves, do I have access to bring in a big block system, or is it the access is limited, so I have to do more of a hand place wall system? So those kinds of constraints start leading you in a direction one way or the other. Is it a commercial job? Is it a residential job? Like we kind of talked about before, Risi Stone and Unilock offer a huge range of products from appearance wise, but also from a structural point of view. Some do curves really well. Some are better for straight runs, that kind of thing. So the layout, the alignment of the wall is another factor that comes into play, how much space you have to build it. So there's a lot of factors. There's great resources on both the Risi Stone and the Unilock website. The Unilock territory managers are product experts. And, if the contractor has questions, one thing we do here at Risi Stone day in and day out is sort of take the initial glance at a project and say, okay, here's your issues right out of the gate. This is the best product for your application, and provide some guidance in that way. So a lot of times we're not necessarily producing a design. We're just having a discussion with the contractor about what's really going to fit into their site best, given the constraints and conditions and so on.
Obviously, Risi Stone and Unilock, two amazing resources that everyone can go check out. And closing up this interview, Ray, when a contractor has a wall in the planning process, what's the first thing that they should be doing?
Just going back to what Tyler had said, it's really about contacting the territory manager, and they'll take a look at all the parameters with the contractor and get that information back for a design. But in regards to, getting things done by machine as opposed to back labor, definitely, you want to take a look at the Durahold and Sienna, especially if you're raised backyard up like 6 feet or 7 feet, because there's a pool going in and you've got to level off the property. These are perfect products because usually that site's torn up anyway because of the pool, and there's machinery in there, and you can get these big heavy duty walls put in. And it certainly gives the customer a lot of mind to see these units go in, and they can go in It's just a lot easier than handwork. In our U.S. operations, we have a product called Pisa XL, which is a wide version of Pisa 2, and that can be put in with our Unilift. I know, Mike, we've talked about the Unilift machine already, but Unilift easily picks up these blocks. They're 70 pounds each. It could be a lot of hard work to do that by hand. And again, the Unilift allows you to put in sort of what appears to be a hand-placed unit with a machine, making it much easier.
Absolutely. And so much great information in this podcast. And Ray and Tyler, thank you so much for your time, but also thank you so much for taking a topic that would be, better off shown visually, and really taking it and putting it into a very simple verbal approach with this podcast. Lots of great information, lots of great explanation. Tyler, let's start with you. Where can our audience go to learn more about Risi Stone and everything that you guys are about?
Yeah, I think obviously the main place would be risistone.com. We've actually spent quite a bit of time over the last 2 years totally revamping the website, trying to make it easier to access all the resources that we have available there. So one of the main things I kind of wanted to point out, we have a new wall estimation tool, which is really an industry first. It allows the contractor to go in and basically just draw a plan view of the wall. You could do it on an iPad, you could do it on a PC, whatever. Enter in a few grades, and it actually will generate a quick estimation of your wall quantities in terms of your geogrid, your backfill, the face area of the wall, coping, corner units, everything. So it's a pretty unique tool. Again, it's on risistore.com under the resources. And we have all of our installation guides posted there for just about every product, PDF form, you can print them out. We have a whole library, literally hundreds of typical cross sections in CAD and PDF that you can do a quick search on. Just say the wall type you want, the height you want, and it'll go through this huge library. Same thing with details. We have CAD and PDF details for just about every wall system, for everything you can think of, from installing a handrail to building a corner. They're all there. They've been built up over many years, and it's just a wealth of resources in there. So that's where I'd say go first, and then obviously give our engineers a call. That's what we're here for, and we can take a look at your projects and help you through to the best solution.
Excellent. And that's an awesome resource that our audience should definitely check out. And Ray, turning it over to you, where can our audience go to learn more about Unilock?
Well, they can go to unilock.com, of course, and certainly, from an images perspective, we've tapped into, of course, all the Risi Stone resources, but the most comprehensive resources, you will find at the Risi Stone site. If a contractor is looking to learn more about the appearance and the project types, I would suggest even for them to hashtag any of do a search on Instagram and for the hashtags of any of the products. So hashtag Durahold, hashtag Pisa, hashtag Sienna Stone. Way they can see images and applications and projects, and this might even help them in their sales process.
Thank you for listening to today's podcast episode. Visit us at howtohardscape.com for more information on this subject. Let us know what you want to learn about in future episodes by reaching out to us on our social channels. We are at How to Hardscape everywhere. And once again, thank you to everyone that has been sharing this episode, tagging us at How to Hardscape on Instagram, Facebook, wherever you might be sharing it. And also to those who have been taking the time to subscribe to our podcast and leave us a review on Apple Podcasts. We really appreciate these coming in. And thank you so much for just tuning in each and every week to these episodes. We hope you're getting lots of valuable information from these episodes, and we look forward to meeting with you next week on the How to Hardscape podcast.